Here we're gonna see the octal numbers. There is nothing really new about this. This is just a different base, and that's gonna be base 8. So this is used in some cases. One example is like Linux permissions that are using octal numbers. The digits for base 8 gonna be obviously 0 to 7. So we have 8 digits, and every rule that we talked about, it's gonna apply. So for example, if you are converting from your base 8 to base 10, so from your octal to your decimal, you can do the same thing. You index them 0, 1, 2. You have the value for each of them, which is a to the power of 0, a to the power of 1, and a to the power of 2. So that's the value for each position. And then you multiply each digit to its value, and then you sum them, and you get your decimal. So nothing new here, same process, except that this is 8. And there is one interesting thing here, that each octal digit represents 3-bit in binary. So what does that mean is that you can directly convert from your octal digit. So for example, if you have 1, you can directly convert this to binary. So if you want to convert from base 8 to base 2, you can convert each digit. So if we have here, I can write every digit. So 0, 1, 2, 3, 4, 5, 6, and 7. And that's our binary, our octal digits in base 8. So what is these numbers in binary? If I put 0, and I'm gonna put all of them in 3 digits. So 0 gonna be 0, 0, 0. 1 gonna be 0, 0, 1. 2 is going to be 0, 1, 0. 3 is gonna be 0, 1, 1. 4 is 1, 0, 0. 5 is 1, 0, 1. 6 is 1, 1, 0. And 7 is 1, 1, 1. So this is octal, and this is binary. So nothing here like fancy, it's just I'm putting each digit, each number in octal, and I'm writing the binary representation of it, and I'm using 3 digits only. So you see the maximum that we have is 7 with 1 digit, and that's gonna be 1, 1, 1 in binary, and the 0 is all zeros. So there is like all in between. So what we can use here, if you want to convert directly, so from base 8 directly we want to go to base 2, we can basically replace each digit to the binary representation. So 1 gonna be 0, 0, 1. 2 gonna be 0, 1, 0, as you can see here. 7 gonna be 1, 1, 1. And basically there you have your number, which is 87 in decimal. You can convert it quickly to binary. So we have the hex number here. Basically every rule that we talked still is the same, except that we have so this is base 16, so we have 16 digits, right? So what happens when you run out of your 0 to 9? When you want to put 10, we are using the alphabets. So because you don't want to have 1 0, how do you know if that's like 1 digit and 2 digits, right? So after 9, it's basically we are switching to A, B, C, D, E, F. And that's the only different thing that we have in hex number. The numbers are prepended like basically with 0x to show that is hex. So whenever you have 0x 1, 2, 3, so that's a hex number. So this is just like a representation. And I think in binary we are putting, depends on the language. I think in Java you put 0b, I think 0o for octal. You can actually like writing code like that, and the compiler understand this. But basically this is just like saying that there is a hex number, and those are your digits. Hex is used a lot in memory, the RBGA colors, so basically the colors that you are using on web, if you see, for example, you have FF, I think that is white, 6Fs. So you have, I think each two gonna be like red, green, and blue, right? So this is unlike HTML, you're using this a lot. And memory addresses are all in hex. But again, the rules are the same, like nothing is new. So for example, here, if you are converting a 3-digit hex into decimal, so you have 4FF. If we put the index, that's 0, 1, 2. So there is going to be 4 times 16, because the base is 16, right? To the power of 2. And then F is 15 times 16 to the power of 1. And then again, F another 15 times 16 to the power of 0. And you basically add them up and you get your number. So this 4FF in hex is actually 1279. So the same rules apply. Let's continue. We talked about the two methods that we can convert our binary numbers to our hex numbers. So we can use the same method in your hex actually to convert any decimal number to a hex number. So let me try to write. Okay, so this just gonna be a bit more tricky because the numbers are bigger. So if we go with 16, I think 16 to 0 is 1, 16 to 1 is 16, and then 16 to 2 is 256. So, and that's what we need for this number. So 305, the biggest power of 16 gonna be 256. That is smaller than 305. So we can have one of those. And then if you do the math, basically 305 minus this number, and should I maybe do it? So 305 minus 256. This we're gonna get 15. Just jumping. Here we're gonna get 10, and then 9, and this gonna be 2. So 15 minus 6, that's gonna be 9, and then 9 minus 5, that's gonna be 4. So we're gonna get 3 times 16, that's gonna be 48, and then we have 1 remaining. So there is gonna be 48. And 1. So that's only 1. So basically, this is what we're gonna get. You break it down. And there is the other method. We have divide by 16. So you have your decimal number, divide by 16. So let's try. So 966 divide by 16. So I'm gonna cheat here because I'm seeing the answer. So if we are doing these 2 digits, I'm gonna get a 6. So 6 times 6, that's 36. And then 6 times 1, 6 plus that 3 is gonna be 9. So that's perfect, 96, 0. And then we have a 6 drop down and 0. We cannot have more. So that's our remainder. There's 6, and this is our quotient. So 60, and then remainder is 0. Sorry, remainder is 6. If we take this 60 down and continue the same way, we're gonna get 3 remainder 12. So basically we continue this, and we're gonna get this from bottom up. So 3, 12, 6. We write, so 0x is just a notation that is a hex number. 3, this was C. If you look at the table in the previous slide, So here we have C is 12, and I have to go back forward. Okay, so 3, 12, that's C, and then the 6. So that's gonna be 966 in hex. So basically that's a two-way to convert. Exactly same rules, except that we are working with 16. So let me clear this and continue. So these are, okay. So these are converting our basically hex. Well, there are three things here. So hex to binary, so that's base 16 to base 2. That is base 2 to 16, and then 16 to 10. So we are doing three different things here. For binary, that's going to be the special case that you can convert each digit of hex to your binary. So 5 is 0101. We can do the table again for all the numbers, and then you can see that like number 5 gonna be 0101 in binary. A is 1010 in binary. So A was, let me just like do this one. A was 10, right? And if you're converting these, so 0, 1, 2, 3. So that's 8 plus 2, right? So that's 2 to the 3 plus 2 to the 1. So that's 8 plus 2, that's 10. So you see basically it's each digit. And if you have this, we basically convert each digit to the binary and we are done. So 5 is 0101, A is 1010, and then another A 1010. So that's our binary representation of this number. That I'm not sure what is in decimal. Here is the other way around, and exactly the same thing works. So if we know each 4-digit, and you can pad them by 0 so far at this stage. So 0110 is 6, 1010 is A or 10, and basically that's gonna be 6AA. So there you go. So there is from 16 to 2 and 2 to 16. So these are very, very easy. And then we have our hex to decimal. So if 1 to A, so the main way that we know is gonna be we index them 0, 1, 2, and then we're gonna use, so this is base 16, right? We're gonna use 1 to the 16, so 2 times 16 plus 2, sorry, that's 1. This is 1, the first one. 1 times 16 to the 2, and then 2 times 16 plus 10, and times 16 to 0, which is 0, which is 1. So if you add this, we're gonna get the answer. But here we are showing a different way, and that is basically converting, basically using this thing that we have here. We convert that number to binary first, and then we are using powers of 2. And the rationale behind this is that many of us know the powers of 2. So you say 2 to the 8 is 256. So it might be a shortcut for you if you want to convert it from this way. And for 2, it's very easy because like it's either 0 or 1. So if it's 0, it's completely ignoring. So here we have like 2 times something. So we have a multiplying step. So not only you have to know these powers of 16, but also you have to know like calculate the power of 16 and then multiply it by something. But here it's either 0. So if it's 0, we don't have it. If it's 1, it's just that power. So here is 0, 1, 2, 3, 4, 5, 6, 7, 8. So we have 2 to the 8, 2 to the 5, 2 to the 3, 2 to the 1. And if you know this, it's going to be very easy to add this and get the answer.